Good morning to all of you. Today we will start chapter 5 of class 11, complex number. This is the first part of this chapter. Today this is the complex number. What is complex number? In previous class 10 we solved a question. Let ax square plus bx plus c is equal to 0. This is the quadratic equation in variable x. Quadratic equation in variable x. Now, the value of x is equal to minus b plus minus b square minus 4ac upon 2a. We find the nature of roots by a formula d is equal to b square minus 4ac. It means d. What is the d is called discriminant. D is equal to b square minus 4ac. And when the value of d is greater than 0, it means two distinct real roots. Now, if d is equal to 0, it means two equal real roots, and when d is less than 0, it means imaginary roots. Now, in class 11 we will discuss about when d is less than 0. Here you can see easily that when this part is negative, it means d is less than 0. What is the meaning of this statement? It means this part is in negative part. This is the value of 4 is equal to 2 and minus 4. What is the value of this? So we will discuss about what is the value of this in this chapter. Ax square plus bx plus c is equal to 0. This is quadratic equation. The value of d is the nature of roots. When d is equal to 0, it means two distinct real roots. The value of d is equal to 0, it means two equal real roots, and the value of d is less than 0, it means imaginary roots. Now here complex number is form of, first of all we erase this part. Now, if this is minus 4, what is the value of this? Minus 4 can be written as 4 into minus 1, 4 into minus 1, and there are a Greek word iota. This is the Greek word iota. The value of I is equal to minus root 1. The value of I is equal to minus root 1. The value of I is equal to minus root 1. It means I square is equal to minus 1. So we can write the value of this is plus minus 2. Now the minus 4, it can be written as minus 4. So minus 4, it means 4 into root minus 1, 4 into root minus 1, and the value of 4 is equal to plus minus 2, and this value is equal to I. So there are two values, plus 2i and minus 2i, and this number are imaginary number because here is terms I. This is not a real number. This is imaginary number. Root 4 similarly minus 16. So the value of this is equal to plus minus 4i. This is an imaginary number. So this is very useful concept. I is equal to minus square root minus 1, and I square is equal to minus 1. And I square 2 whole square is equal to minus 1 square. It means I to the power 4 is equal to plus 1. So here we concept use I is equal to square root minus 1. and another I square is equal to minus. Now the formation of complex number is the denotation of complex natural number is denoted by n, integer is denoted by capital Z, all letters are capital, and rational number are capital R, irrational are T. So complex number are denoted by Z. Z is equal to a plus ib, a plus ib. The formation of Z is equal to a plus ib. Here a is the real number, and b is imaginary number. It means a is real number and b is real number. Now 3 is a natural number, 3 is whole number, 3 is a rational number. Is 3 is a complex number? Is 3 is a complex number? This is a question. Is 3 is a complex number? Is 3 is a complex number? Write the answer in comment box. So now the Z is equal to a plus ib, and a is real and b is imaginary. Now Z is equal to 3 plus 2i. Here the value of a is equal to 3 and the value of b is equal to 2. Here the value of a is equal to 3 and the value of b is equal to 2 by comparison this complex number. Now conjugate of complex number. Now if two complex number, there are some concepts. If two complex number are equal to each other, if two complex number are equals to each other, it means real part is equal to each other and imaginary part is equal to each other. Let's take example. If z1 is equal to x plus iy and z2 is equal to 5 plus 3y, and question is said that if z1 and z2 are equal, then find the value of x and y. So z1 and z2 given z1 x plus iy is equal to 5 plus 3. Here we comparison with real number to real number and imaginary number to imaginary number. So the value of x is equal to 5 and the value of y is equal to 3. Now take another example. If z1 is equal to z2 and the value of z1 is equal to x plus iy and z2 is equal to minus 3 minus 2y. So find the value of x. It means x is equal to minus 3 and y is equal to minus 2. Now take another example. If 5 plus 3i is equal to x plus y plus x minus y. This complex number and this complex number are equal to each other. It means real part is equal to real part and imaginary part equal to imaginary part. It means x plus y is equal to 5 and x minus y is equal to 3. So here these are some examples. If two complex number are equal to each other, then the real part is equal to real part and the imaginary part is equal to imaginary part. Now we move conjugate of complex number. Conjugate of complex number. Now we discuss about conjugate of complex number. What is the meaning of this word conjugate of conjugate. So first of all, take a complex number. Z is equal to a plus ib. This is the complex number. Here real part, real z is equal to a and imaginary z is equal to, we can write in this form, re means real part of this complex number is equal to a and im means imaginary part of this complex number z is equal to b. So we talk about conjugate of complex number. So if z is the complex number, then the indication of conjugate of this complex number is equal to z to the power bar. Z bar. It means the conjugate of this is z bar is equal to, so here also a plus ib bar. A plus ib bar. And this form is changed is a minus ib. In the conjugate of complex number, the sign of imaginary number is changed. If the sign of imaginary has plus, then after conjugate it will be minus, and if this is plus and if this is minus, after conjugate this is plus. So if z is equal to a minus ib, so the conjugate of this z is equal to a minus ib, and now it can be written as a minus, it means this is plus ib. Here we can talk about imaginary number, not effect on real part of conjugate. So we can change only the sign of imaginary part. We can change only the sign of imaginary part when write the conjugate of complex number. So this is the formation when z is equal to a plus ib, z bar is equal to a plus ib bar. Now z bar is equal to a minus ib, because this is plus, so this is minus. Now z is equal to a minus ib, so z is equal to a plus ib. Take an example. If z is equal to 2 plus 3i, this is a complex number, this is real part 2, imaginary part 3. Now take a conjugate 2 plus 3i. So change the sign. 2, this is plus, so this is minus. This is minus. Now, if z is equal to minus 2 plus 3i, so conjugate of z is minus 2 plus 3i. The effect of conjugate is not on real part, is effect on only imaginary part. So here this is plus, so we can write minus 2 minus 3. Now, take another example. Z is equal to minus 3 minus 4i. So, minus 3 minus 4i, it means z bar is equal to, this is minus 3, this is minus, so this is plus 4. So, this is the conjugate of complex number. So, further proceed, please pause the video and note it down. Now, there are some property of conjugate number. Now we move on exercise 5.1. Exercise 5.1. Chapter 4, the principle of mathematical inductions is completely reduced in this year. So we will not discuss about principle of mathematical induction. So we start chapter 5, complex number. So we move on exercise 5.1. Here. Express each of complex number given in exercise 1 to 10 in form a plus ib. एक्सरसाइज 5.1 में जितने भी क्वेश्चन गिवन है उसको आप a प्लस आई फॉर्म में कन्वर्ट करो. लेट सपोज इफ यू गिव 5, कन्वर्ट इन दिस फॉर्म, सो वी कैन राइट इट 5 प्लस i into 0, 5 we cannot, this is the form of a plus bi is not a plus ib is the correct form of complex number, so we can write always z is equal to a plus ib, not a plus b. So 5 is equal to 5 plus I into 0. This can be written in form a plus ib. So in question exercise 5.1, every part convert into a plus ib. Now first part is question number first, 5i into minus 3 by 5i expressed in a plus ib form, a plus ib. So here we can say that we can write 5i into minus 3 by 5 into 5 cancel out, and I into I, that is I square, and this is minus 3. It means minus 3i square, and we already know if I is equal to square root minus 1, then the value of I square is equal to minus. So we use this concept, I square is minus 1, I square is equal to, so minus 3 into this part is minus 1, so this is minus minus plus 3, and plus 3 can be written in form 3 plus I into 0, 3 plus I into 0. Now check the answer. So this is 3 plus I into 0. This is converted into a plus ib form. 3 plus I0 is equal to a plus ib form. Here imaginary part is 0 and real part is 3. So further in question number 2, question number 3, question number 4, 5, 6, 7, 8, 9, 10. Now we move on question number 2. This is the first question. Question number 2. Question number 2 is I to the power 9. This is question number 2 plus I to the power 90. I to the power 90. What is the value of this number? Again we use I is equal to square root minus 1 and I square is equal to minus 1. This is the most important concept. Now, I square can be written as I to the power 9 can be written in form I square to the power 4 into I, because a to the power m into a to the power n is equal to a to the power m plus 1, m plus n. Here this is I to the power 8 and into I, it means I to the power 9, so I to the power 8 plus 1, that is I to the power 9. So here we use concept I square whole square 4 into I. Now again we use in this concept I square to the power 9. 9 to the 18 into I. So here we can say that I square is equal to minus 1. I square is equal to minus 1. So here this is minus 1 to the power 4 into I plus minus 1 to the power 9 into I. Now minus to the power even number, it means already positive, so this is positive I, and minus to the power odd number, it means minus, so this is minus I, and minus I and minus I, so this is cancelled out, so we obtain only 0, and 0 can be written in form 0 plus I into 0 plus I into 0. This is the form of a plus ib. So here this is the complete solution of question number 2 of exercise 5.1. Now question number 3, 4. In next video we solve further questions. So please pause the video and note it now. Thank you.